Okay, this little video is about congruent triangles in an isosceles triangle. And first, we're going to remember an important property of an isosceles triangle by looking at this small animation in GeoGebra. So here we have triangle RST. It's any triangle you might find where the median from the vertex, the angle bisector from the vertex angle, and the altitude from the vertex angle are all different segments. And the perpendicular bisector is clearly different. But look what happens as S moves from anywhere to a point on the perpendicular bisector. Suddenly, all those lines merge, and the median, which intersects the midpoint, the altitude, which is perpendicular, and the angle bisector, which bisects angle S up here into two congruent angles, are all the same. That produces congruent triangles. Okay, so here is triangle RST again. I took a snapshot of it so we could examine it, and I verified that everything that I just said was true is true for this example. Right now it's just an example. So I verified that the two sides, SR and ST, are both 14.1 because GeoGebra measured them. I verified that SM is not just a median, which divides RT into two segments 8.8 in length, but it's also perpendicular because this is 90 degrees over here at angle M. And it's also an angle bisector because both of the angles that S is divided into measured at 38.5. I am only pointing this out to make it clear that we haven't proven this, but we have verified it in GeoGebra. So now we're going to look at the congruent triangles we have. Since all the pairs are congruent, the pairs of the sides opposite the 90-degree angle, the 90-degree angles, the base angles in the isosceles triangle, which we verified at 51.5 degrees, all the corresponding parts are congruent. And that's what we have to talk about. What does it mean that corresponding parts are congruent? Well, it means that when we write a congruent statement, like triangle RSM is congruent to triangle TSM, we have to put the congruent angles in corresponding order. Angle R is congruent to angle T, so they're in the same relative position. And that should mean that the corresponding segment names are in corresponding order. So RS is congruent to TS, so they're in the same first two positions. So we could also write triangle MRS, see we're naming it differently, is congruent to triangle MTS because everything is in corresponding order. The two angles at angle M, they're both 90 degrees, they're congruent. Angle R and angle T, the base angles at 51.5 degrees are congruent, and they're both in the middle position now. And the two angles at S, the two parts, the equal parts that the bisector created, are in the same position. We call this phenomena corresponding parts of congruent triangles are congruent. Because when we state something, we state that these two triangles are congruent, we now know all the corresponding parts are congruent. That also means we can't just write congruent statements any way we want. So we can't write triangle SMR is congruent to triangle STM. We can't write this because angle M is not congruent to angle T. In SMR, angle M is over here, and that is not congruent to angle T. But in this statement, that's the position they've been put in. So this would be wrong, and that's why I didn't put a congruence. I wrote is not congruent. So you're going to encounter many of these congruent statements, and now you know that there is so much information to be gathered. 6 corresponding congruent parts from every congruent triangle statement.